Hello friends, today's question. A car P is moving with a uniform speed of 5 square root 3 meter per second towards a carriage of mass 5 kg at rest kept on rails at a point B as shown in figure. The height AC is 120 meter. Cannonball of 1 kg are fired from the car with the initial velocity of 100 meter per second at an angle 30° with the horizontal. The first cannonball hits the stationary carriage after time t0 and sticks to it. Determine the t0. At t0, the second cannonball is fired. Assume that resistive force between the rails and the carriage is constant and ignore the vertical motion of the carriage throughout. If the second ball also hit and sticks to the carriage, what will be the horizontal velocity of carriage just after the second impact? So let's draw the figure first of all. So it is given, it is a car P which is moving with a uniform speed of 5 meter per second towards a carriage of a mass 9 kg, and that is kept somewhere here. So this is the carriage. Let us say this is B, and this is point A, and this is point C, and this height is given as 120 meter. AC is 120 meter. So first case, a cannonball is fired from this position such that it sticks to the carriage after time t0. So we are supposed to find out what will be this t0, and it is given that initial speed of that cannonball is 100 meter per second. So this is, let us suppose, u, which is making an angle of 30° with the horizontal, and u is given as 100 meter per second. So in this case, it is given the initial velocity of the cannonball is 100 meter per second. Okay. So you can say that here it is not mentioned that the velocity of cannonball is with respect to the car. It is straightforward mentioned the cannonball has an initial velocity of 100 meter per second. So in this case, it is normally a presumption that the velocity of ball is given with respect to the ground, unless until it is specifically mentioned that it is given with respect to the car. Okay. So we can write it same thing. We can say the velocity of ball is relative to the ground, unless and until it is mentioned in the question in the question, the velocity is always with respect to ground. The velocity is always with respect to, or we can say always relative to ground. So in this case, we can say that the relative velocity of cannonball with respect to ground is 100 meter per second. So this is our cannonball. It is being fired with initial velocity of u, which is given 100. So this is angle of 30°. So you can divide into two components. This will be ux, that is horizontal, and this will be our uy, that will be our vertical component. So we can find out the horizontal component of the velocity of the cannonball. You can say horizontal component of velocity of cannonball which is given as ux, and that will be u cos of 30, or we can say u is given as 100, so 100 3 by 2. We can say that ux is equal to 50 root 3 meter per second. Now similarly, we can find out the vertical component of velocity. The vertical component of the velocity of cannonball, which is called u of y, and that will be u sine of 30, and u sine of 30 is 1 by 2. So you can see u of y is equal to 100 1 by 2. U of y is equal to 50 meter per second. And it says that in the first case, the cannonball is going to strike the carriage after time t naught. Okay. You can see if the cannonball strikes the carriage at t is equal to t naught. So in this case, this is our carriage, and this is a cannonball like this, and this time is given as t naught, and the vertical displacement that is being covered by the cannonball is 120. This is vertical displacement. Obviously it will be negative. Okay. So we can say s of y is equal to u of yt plus half ay t naught. Sy is minus of 120 and uy is our 50, so this comes 50 t naught plus half ay is minus of 10, sorry, this is square, and this is t naught square. So we can write this equation as t naught square minus 10 t naught minus 24 is equal to 0, and it can be factorized into two factors. T naught square, this will be minus 12 t naught plus 2 t naught minus 24 is equal to 0. We can say t naught, this will be t naught minus 12 plus 2 t naught minus 12 is equal to 0. From here we can say it will be t naught plus 2 or t naught minus 12 is equal to 0. So from here it can be said that either t naught plus 2 is equal to 0, or we can say t naught minus 12 is equal to 0. In the first case we get t naught equal to minus 2, So obviously time cannot be negative, so we are going to ignore it. And the second case we get T naught is equal to 12 seconds. So it means the first cannonball is going to strike the carriage after time 12 seconds. Means first cannonball hits the carriage, or you can say hits the stationary carriage after time T naught, which comes out as 12 seconds. Now we come to the B part. In the B part, the second cannonball is fired out as soon as the first cannonball reaches the carriage. It means the second cannonball is being fired after time T naught. So B part. And during the entire motion of the cannonball, the horizontal velocity of the cannonball will be same. Therefore, we can say just before cannonball hits the carriage, its horizontal velocity will be equal to ux, and which we already calculated is 50 root 3 meter per second. And after, because of the cannonball, initially the carriage which was stationary will start to move with some velocity. So we say let the velocity of carriage plus cannonball system after being struck is V2. Now we can use the conservation of momentum. Okay. You can say by conservation of momentum, you can say momentum before collision, or you can say before collision will be equal to momentum after collision. Momentum before collision will be equal to momentum after collision. So which basically means mass of the cannonball multiplied by the horizontal velocity of the cannonball cannonball. So this is the momentum of the cannonball plus mass of the carriage mass mass of the carriage multiplied by the velocity of the carriage so this is the initial momentum of the carriage, and this will be equal to, now the ball's stuck on the carriage, so we can say this as mass of ball plus carriage multiplied with their combined velocity, which is given as v2. And mass of the cannonball is given as 1 kg, so this will be 1 kg, and the horizontal velocity of the cannonball we already know is 50 root 3, so this will be 50 root 3, and mass of the carriage is given as 9 kg, but initial velocity of the carriage is 0 in the first case, which is equal to mass of the carriage and ball, that is 9 plus 1, and multiply by v2. So this comes 0, this is 9, 10, so we get v2 is equal to v2 is equal to 5 root 3 meter per second. So this is the velocity of a, you can say, carriage and cannonball. Now it is given that the second ball is fired at t naught, the second cannonball is fired. It is given that second cannonball is fired at t naught is equal to 12 seconds. So basically we can say from here that second cannonball is fired as soon as the first cannonball hits the carriage. Second cannonball is fired after first cannonball hits the carriage. So in this case also we can say t naught is equal to 12 seconds. So, and the time taken by the second cannonball to reach the carriage will be also 12 seconds. Okay. So we can find out the distance moved by the carriage as well as cannonball during this 12 seconds. You can see from here distance moved by the carriage plus cannonball system in 12 seconds. So let us call that distance as SC, and that will be equal to 12 multiplied by V2, and V2 we already calculated is 5 root 3, so this is 12 multiplied by 5 root 3, or we can say SC is equal to 60 root 3 meters. So this is the distance traveled by the carriage after 12 seconds or with 12 seconds. Now it is given that the vertical displacement rather, that will be traveled by the second cannonball will be also 120 meter. You can see as the vertical displacement traveled by the second cannonball is also minus 120 meter. Therefore, it will also take 12 seconds to cover that vertical distance. That vertical displacement. Now we already calculated that the velocity of the carriage as well as first cannonball when the second cannonball is going to strike the carriage is 50 root 3. You can write it here that at the time of second cannonball collision, the horizontal component of velocity will be also equal to 50 root 3 meter per second. And we also know that velocity of carriage and first cannonball system is 5.3 meter per second. And once again we are going to use conservation momentum. So let us suppose that the velocity of the carriage after the second cannonball collision is given as Vf. See, after second cannonball collision, the velocity of the carriage plus, now it will be both first as well as second cannonball, first plus second cannonball system is equal to Vf. So conservation of momentum, so by conservation of momentum, you can say mass of the cannonball multiplied by horizontal velocity of the cannonball horizontal velocity of cannonball plus mass of carriage plus first cannonball multiply by velocity of the carriage and this will be equal to mass of the first plus second cannonball and plus carriage and velocity Vf. Now we substitute the values. So mass of the ball is 1 kg and velocity is given as 50√3 plus 9 plus 1. 9 is for carriage, 1 kg is for ball, and velocity of the carriage, which we already found out, 5√3, and this will be equal to mass of the two balls, first as well second. So this will be 1 plus 1 plus 9 and multiply by Vf. You can say this will be coming as 50√3 plus 50√3 and this will be 11 Vf, or we can say Vf will be equal to 100√3 divided by 11, and which comes as Vf is equal to 15.75 meter per second. So this is the velocity just after the second impact. This is the velocity just after the impact of second cannon ball. So this completes the question. Thank you.